Artificial neural networks, ANNs, are computational models inspired by the structure and function of biological neural networks in the human brain. ANNs consist of interconnected nodes, called neurons or artificial neurons, organized in layers. Each neuron receives input signals, processes them using activation functions, and produces an output signal that is transmitted to other neurons. Here's how artificial neural networks function in machine learning. Input layer. The input layer of an artificial neural network receives input data, which could be numerical values, images, text, or other types of data. Each neuron in the input layer represents a feature or attribute of the input data. Hidden layers. Between the input layer and the output layer, there may be one or more hidden layers of neurons. These hidden layers enable the network to learn complex patterns and relationships in the input data through the process of feature extraction and abstraction. Each neuron in a hidden layer receives input signals from neurons in the previous layer, processes them using activation functions, and passes the output to neurons in the next layer. Weights and connections. The connections between neurons in different layers are represented by weights, which determine the strength of the connections and influence the flow of information through the network. During the training process, the network adjusts the weights based on the input data and the desired output, using algorithms such as backpropagation and gradient descent to minimize prediction errors and optimize performance. Activation functions. Activation functions introduce nonlinearities into the network, allowing it to learn complex and nonlinear relationships in the data. Common activation functions include sigmoid, tanh, ReLU, rectified linear unit, and softmax functions, each with its own properties and applications. Output layer. The output layer of the neural network produces the final predictions or classifications based on the input data. The number of neurons in the output layer depends on the nature of the task, such as regression, predicting numerical values, or classification, predicting categories. Training and learning. Artificial neural networks learn from example data through a process called training. During training, the network adjusts its weights and parameters based on a training dataset and a loss function that measures prediction errors. By iteratively optimizing the network's parameters, the goal is to minimize the loss and improve the network's ability to generalize and make accurate predictions on unseen data. Prediction and inference. Once trained, the neural network can be used to make predictions or perform inference on new, unseen data. The input data is passed through the network, and the output produced by the output layer represents the network's prediction or classification for the input data. Artificial neural networks are used in various machine learning tasks, including image recognition, speech recognition, natural language processing, pattern recognition, and predictive analytics. They are a foundational tool in deep learning, a subfield of machine learning focused on training deep neural networks with multiple hidden layers to learn hierarchical representations of data.